Okay, good evening, students. So small disturbance. So we'll see 17th question, right? So just units will go a little fast. Okay. So Newton per square meters is the unit of. So yesterday I think we have seen this. So Newton in the sense force, right? So divided by area. So meter square in the sense what? Area. So Newton is force, meter square in the sense area. So force per unit area, we call it as pressure. Yes or no? Yesterday we discussed force per unit area, we call it as pressure. So Newton per meter square is the unit of what? Is the unit of pressure. Okay. Next. 18. So units are there. A little fast we can go, right? So SI unit of momentum. Sorry. Next, unit of surface tension. So I think this one also we have seen yesterday. So surface tension. So what is the unit of surface tension? Answer yourself. I think already we discussed in the last class. Force per unit length. So force in the sense Newton, length in the sense meter. So Newton per meter. So surface tension is nothing but force per unit length. That is nothing but Newton per meter. What they gave? Yes, Newton per meter. Next, 19. Just units. Try to answer yourself, right? So SI unit of momentum. SI unit of momentum. So momentum in the sense mass into velocity, right? So according to the options we have to think. See, so in terms of kgs and all it is there. So we can write this. So mass into velocity. Mass is nothing but kg. So velocity is nothing but meter per second. So what is the unit? Kg, meter per second is the unit of what? Is the unit of momentum, right? And next, 20. So I think not going fast. Already we have seen in yesterday's a topic like pressure, force per unit area, and surface tension like force per unit length, and momentum also we have seen in yesterday's class like mass into velocity. So just I have written according to the options. Okay. So next 20, 1 million electron volt. 1 million electron volt. So what do you mean by 1 million electron volt? So 1 million, which indicates 10 to the power 6. Yes or no? 1 million, which indicates 10 to the power 6. So what is the correct option for 1 million electron volt? Just conversion, right? So it will be like 10 to the power 6 electron volts. We call it as 1 million electron volts. It's not 10 to the power 5. It's not 10 to the power 4. It's not 10 to the power 7. Next, 21. See, earth per meter. So earth per meter is the unit of what? So N in the sense what? It is energy, right? And per meter is nothing but the unit of length or distance. So what we want? We want energy divided by distance, or with respect to the meter, whatever the unit you want, we can write. So according to the options, we want this. So see the option checking method again. So first option force. In terms of this, is it possible? Yes. So yesterday we have seen a formula. Work done is what? Force into displacement. So force I can write as work done divided by displacement. So what is work done? Work done is nothing but any forms of energy, right? It will be converted to any forms of energy divided by displacement. So yes, force is the correct option. No need to check any other options. Why? Because we know the formulas. Momentum, power, and acceleration won't be like this. Won't be in the form of energy divided by distance. So force will be your correct option, right? And next, 22, unit of potential energy. Again, same, right? Potential energy is nothing but energy. So energy in the sense it is a unit of work done. So what is the unit? Or else we'll write with the dimensional formula ml square t to the power minus 2. So with respect to this, m indicates what? 1 m, right? So 1 m in the sense kg meter square per second square. So this will be the unit of potential energy. I think they gave in grams. So convert this into grams. So it's kg gram meter per second square. It will be centimeter divided by second whole square. All right. So this is up to 22. Next. So units and dimensions chapter. So we are concentrating more on the units, right? So we are concentrating more on the units, right? And next 23. 23. So what they said, which of the following represent a volt? Which of the following represents a volt? So according to the given options, so volt in the sense work done per unit charge. So with getting 12th, I think you got already in your 10th class, try to revise. Okay. So work done per unit charge, we call it as volt. Only one formula. Think about another formulas what we discussed in the last class. P equals to VI. So V I can write as P divided by I. So based on this, try to write the units. So SI unit I can write as work done is nothing but joule per coulomb, right? So power watt per ampere. Current SI unit is what? Ampere. So now check the options. See, joule per second, no, not possible. Watt per ampere is the unit of volt, possible. And if joule per coulomb is also there, that is also possible. But they gave coulomb per joule in the fourth option, so that is also wrong. Next, 24. So kilowatt hour is the unit of kilowatt. R is the unit of concentrate kilowatt hour. So kilo is nothing but a number. Watt is the unit of power. So watt, kilowatt. I am writing only according to the units. Kilo indicates 10 cube. So apart from that, nothing. So watt per hour. So watt hour. So here R in the sense instead of R, can I write second? Right? So exact unit of R I can write as second. So watt second we want. So for which one it is possible? For which one it is possible? So watt in the sense what? Power. Power in the sense. Watt in the sense what? Power. Right? So power formula rate of work done. Rate of work done into second. Is that no understanding? So watt, which indicates the unit of power. Power indicates rate of work done by time. And into second, so that second I multiplied. So unit of time and second will be cancelled. Is that okay? So now what is W? W indicates work done. Getting the point? So watt is the unit of power. Power in the sense rate of work done. So second. So time SI unit is also second. So second will be cancelled. So work done. So work done unit. What is work done unit? Work done unit is nothing but what? Energy. Energy and work done units both are same or not? So finally what we can conclude, kilowatt hour is the unit of energy. Kilowatt hour is the unit of what? Is the unit of energy. Right? And next. Okay, is the unit of energy. Next, which of the following is a derived unit? No need to write. Which of the following is a derived unit? Mass, fundamental unit. Length, fundamental unit. Time, fundamental unit. Volume. So volume is fundamental unit or derived unit. So volume we have to write it as 3 in L. In a sense, it is derived or fundamental. It is derived. So volume is derived and remaining 3 options are fundamental. So fourth option is the correct option, right? And next, dyne per centimeter square. Dyne per centimeter square or square centimeters is not a unit of. So pressure formula we know, force per unit area, force in the sense Newton SI unit, dyne CGS unit, area square centimeters is the CGS unit. So for pressure, dyne per centimeter square is okay. Next, stress. I think yesterday we have seen stress formula. Answer yourself. Force per unit area again. Yes or no? Again the same possibility will be there or not? Yes. Next, Young's modulus. I think you have to know about this. Young's modulus. You'll get in part 2, first chapter, mechanical properties of solids, modulus of elasticity concept. So modulus of elasticity is nothing but stress divided by strain. So Young's modulus is also we call as stress upon different types of stresses are there, different types of strains are there. It's just generalized point I am writing. So not exactly correct for Young's modulus, but the ratio is the same. Longitudinal stress by longitudinal strain is the exact formula, but you can know the things in that chapter. But commonly we call it as stress by strain. But we know strain has no dimensions. So strain has no dimension. So Young's modulus and stress having the same dimensions and having the same units, which is nothing but dyne per centimeter square is the CGS unit. So for these three, dyne per centimeter square unit is correct. Now what is the other one I left? Strain. So strain having dyne per centimeters, or it is dimensionless? It is dimensionless. Yesterday we have seen. So change in the length divided by length. Yes or no? We call it as strain. So dimensionless. It won't have any dimension. So that option is the correct option. Right? And next, 27 units of angular momentum. I think this formula also we have seen yesterday. Angular momentum. What is the formula for angular momentum? MVR. Yes or no? Angular momentum. So according to the things, what we can write? So write the dimensions. You can understand it easily, right? So MVR. So what is M? Mass. L t to the power minus 1 and again into L. So M, 1 in M, 2 in L and minus 1 in T. So according to the given options, you have to check now. So kg meter square per second square. Those many squares are not there. Alright? Yes or no? So time is not there in squares. It is there in minus 1. So first option is wrong. So second option I think we can consider joule second. Joule second. So joule second. So what is the SI unit of, what is the dimensional formula for joule? Energy. So it will be 1 in M, 2, minus 2 and again into what? Second. So this will be 1, 2 and minus 1. So see, both are same. So joule second and angular momentum dimensional formulas are same. So I can go for second option. So this will be the shortcut. Don't think more about the things. Up to now, we are discussing about the dimension. So go through with the dimension concepts. The questions will be easy, right? And next, 28. Which of the following is not the unit of energy? No need to write. See the options. Which of the following is not the unit of energy? Calorie is the unit of energy. Joule, unit of energy. Electron volt, I think we discussed. That is also unit of energy. Watt. Watt is the unit of power, not the unit of energy. So that is the correct option. Clear about the point? Unit of Young's modulus. I think just now we discussed unit of Young's modulus and stress both are same. That is nothing but dyne per centimeter square or Newton per meter square. So unit of Young's modulus is, what is that? Dyne per centimeter square or Newton per meter square. One femtometer is equals to, femtometer is nothing but Fermi. Femtometer is a device which it measures any length in the form of in the terms of Fermi. So femtometer which measures you 10 to the power minus 15 meters is equivalent to what? Is equivalent to 10 to the power minus 15 in meters. Femtometer, name itself tells Fermi. So 10 to the power minus 15 in meters. Next, 31. Okay, 31. So select the pair whose dimensions are same. Yesterday we discussed, right? So I think just now we discussed. You can compare the things. See, select the pair whose dimensions are same. Pressure and stress. By seeing we can tell. Pressure formula, force per unit area. Stress formula, again force. Dimensions is dimensionless. Stress is force per unit area. So that is wrong. Pressure and force, obviously wrong. Force per unit area is pressure. So wrong. Power and force, wrong. Is that clear about the point? Next, 32. Dimensional formula, M, 1 in M, minus 1 in L and minus 2 in time. 1 in M, minus 1 in L, minus 2 in T. So does represent the physical quantity. which this dimensional formula belongs to what physical quantity. First we'll check with what. So does represent the physical quantity of dimensional formula of this does represent the physical quantity. See, Young's modulus, stress strain. Young's modulus is the first option. Young's modulus. Second option, stress. And the fourth option, I'm going for fourth option, right? So which is pressure. I think all the three will have the same dimensional formulas. Yes or no? So that is nothing but force per unit area. So it is ml t to the power minus 2 divided by area is what? Area is L square. So I can write it as 1 minus 1 t to the power minus 2. So 3 will satisfy this. Now what is the question? Dimensional formula does represent the physical quantity. I think does not represent, I think, right? Yes. Does not represent the physical quantity. I folded the paper, don't mind. Okay. So does not represent the physical quantity. So these three represents this. So what is the correct option? Strain. Clear? Next. Dimensional formula. Next the same thing. 1 in M, 2 in L, and minus 3 in T. Represents what? So first option, force, power, energy, and work. So force, I think by seeing we can tell ml t to the power minus 2. In the sense minus 2 in T, generally we call like that. Ml t to the power minus 2. So wrong. Energy 1 in M, 2 in L, minus 2 in T. Wrong. Work and energy both are same. So obviously we can go for power. So power is rate of work done. So work done ml square t to the power minus 2 divided by time. So see m 1 in m, 2 in L. So 1 in D will go to the numerator. So minus 2 minus 1 minus 3. So power will be your correct option. Right? And next. Okay. See the next question. 34. Dimensional formula for angular velocity. Now dimensional formulas. Angular velocity dimensional formula. What do you mean by angular velocity? Yesterday we have seen. So angular velocity represented with omega. I think yesterday we have said, try to revise the yesterday's formulas. Angular velocity is nothing but angular displacement divided by time. Yes or no? Angular displacement divided by time. So theta, plane angle, dimensionless. So only time which is there here the unit. Theta is the dimensionless unit, right? So theta is dimensionless, so only t is there. So 0 in m, 0 in L, t to the power minus 1 will be your correct option. Right? Only time, that too in the denominator, so t to the power minus 1. Okay? So first option. Yes or no? So next 35. What is that? Dimensions of power. I think just now we have seen. No need to write. Yes or no? Rate of work done. M L square t to the power minus 2 divided by T. 1 in T. Right? So finally 1 in M, 2 in L, minus 3 in T. So just now we discussed that is the dimensions of what? Power. Clear? Next, dimensions of couple. Couple is nothing but rotational effect of force. So we'll get in, I think, system of particles and rotatory motion. So couple and torque concepts are same. So torque in the sense force into perpendicular distance. Force into perpendicular distance. Try to write this formula, right? So couple, which indicates the concept in the torque, that is nothing but force into perpendicular distance. So according to the units, force units. Can I write it as units? So Newton meter. So Newton indicates ml t to the power minus 2 and meter is again L. So it will be 1 in M, 2 in L and minus 2 in T. First option. Getting the point? So couple, which is in the concept of the torque. So the formula force into the perpendicular distance. So this will be the dimensional formula. Next, 37. Dimensional formula for angular momentum. I think formula we have seen in the last class. Angular momentum. So what is the formula for angular momentum? Answer yourself. m, v, and r. Yes or no? So mass, velocity, and radius. So try to write the dimensional formula. 1 in m. So velocity 1 in L, minus 1 in T, and again R. R is perpendicular distance. So L power 1, again L power 1. So it will be 2 in L. So this will be the dimensional formula for angular momentum. Try to write all the formulas and dimensional formulas and the name of the physical quantities like a tabular column. Then it will be easy for you for the exam, right? So next 38. The dimensional formula for impulse. Impulse. What do you mean by impulse? It is nothing but force into time. So concept is there, not exactly correct according to the concept, but according to the formula we can consider. Okay. So impulse is nothing but force acting on a body in a very short interval of time. So, but according to the dimensions and according to the formulas, we can write like this. Don't worry about that. So, force and time, right? So, force is nothing but Newton and second. So, this will be the unit. Now, force Newton we know mm t to the power minus 2, and second, and again t. So, it will be t to the power minus 1, 1, 1. So, this will be the unit of what? Unit of impulse. Alright. So, unit of impulse and dimensional formula for impulse 2. Right. Next 39. The dimensional formula for impulse is same as the dimensional formula for momentum. So very important question. Try to write that in the note. Impulse and momentum will have the same dimensions. Will have the same dimensions. Right? Momentum. What is momentum formula? I think in today's class also we have seen, that is mass into velocity. Mass is m, velocity, right? 1 in L and minus 1 in T. So if I didn't write anything on the powers of either m or L or T, that indicates 1. Don't be confused. Okay. So if I didn't write anything to the power of m, what it indicates? 1 is there. Okay. So 1 in m, 1 in L, and minus 1 in T. See, both dimensional formulas are same or not? Yes. So like here, what is another formulas? What we discussed? Young's modulus and pressure, stress and pressure, same dimensions or not? Likewise, this is another pair called impulse and momentum will have the same dimensions. Okay. And next, which of the following is dimensionally correct? So we have to check the dimensions. Okay. So we'll check. We'll check the dimensions. Which of the following is dimensionally correct? So pressure, which is equals to energy per unit area. According to the options I am writing. Pressure which is equals to energy per unit area. Absolutely wrong. Why? Pressure is what? Force per unit area. Force and energy are same. No, work done and energy are same. Force and energy are not same. So by seeing we can tell this is wrong. Yes or no? Next. Pressure which is first option. Next, second option. So pressure equals to energy per unit volume. Energy per unit volume. We can check once. Why? Because energy per unit volume, chances are there. So energy is nothing but, can I write instead of energy work done? Why? Because both are same. Why? Because the formula we know, or dimensionally also you can prove. It depends on your comfortability level. Don't worry about that. So, okay, we'll solve with dimensional formula. Energy dimensions, 1 in m, 2 in L, minus 2 in T, divided by volume will be 3 in L. So, which is equals to 1 in m. So, how much? Minus 1 in L, and the time same, minus 2 in T. So, this we got. Right? So now for pressure, what is the dimensional formula? Force per unit area. So m L t to the power minus 2 divided by L square. So it will be minus 1 and 1. See, both are same or not? 1 in m, 1 in m, minus 1 in L, minus 1 in L, minus 2 in time, minus 2 in time. So both are correct. So LHS equals to RHS. So second option is the correct option. Clear about the point? So second option is the correct option. Remaining options also you can check if you want. All right. And next. Okay. Next. So 41, Planck's constant Planck's constant has the dimensions of Planck's constant. What is the formula for Planck's constant? Energy, which is equals to h. H indicates Planck's constant into frequency, mu. E equals to h mu. This is not v, velocity. This is mu, which is frequency. Mu is what? Frequency. So h I can write as energy divided by frequency. So this is Planck's constant. So what they are asking, Planck's constant has the same dimensions of, right? So first we will derive the dimensions of this. What is that? M, 2 in length minus 2 in time divided by frequency. Frequency and time period are inversely proportional to each other. Yes or no? We studied in the lower classes. Frequency and time period are inversely proportional. So instead of frequency, what we can write? 1 upon t in dimensions. This t will go to the numerator. So it will be 1 in m, 2, and this will go to numerator, minus 2 plus 1, minus 1. See, this is the unit of what? Unit of Planck's constant, or dimensional formula for Planck's constant. Now, go to the concept energy. Directly orally. See, orally we will discuss energy. What is the dimensional formula? 1 in m, 2 in l, minus 2 in t. ml squared to the power minus 2. Minus 2 in t. So energy wrong. Linear momentum mv. So 1 and 1 in m, 1 in l, minus 1 in t. So but here 2 is there. So that option is also wrong. So next, work and energy both are same. So A and C both are wrong. Next, finally, angular momentum. I think we checked. We know that mvr. Check this. 1 in m to the power minus 1, and again r is there. So it is 2. So I think both are same. So angular momentum will be the correct option. Remember the formulas. Angular momentum m, v, and r. Okay. So next, 42. From here, some questions. The concept will change. Try to switch your mind to principle of homogeneity, right? So 42, they gave an expression. See that P plus A by V square into V minus B, which is equals to RT, where P is pressure, and V is volume, and T is absolute temperature. So I'm writing it as temperature. Okay, and A, B, and R are constants. Okay, the dimensions of A are. So the dimensions of A are. So they're asking the dimensions of A. Okay, so see now. Whenever if you see these type of expressions, not only this question, try to understand the concept. Whenever if you see these type of questions, we studied a concept before the dimension, some concepts, principle of homogeneities and all, right? So same quantities only can be added and same quantities only can be subtracted. So different quantities might be multiplied, might be divided. Yes or no? Might be multiplied, might be divided, but addition and subtraction on what? On the same quantities or on the different quantities? On the same quantities. So I can tell by seeing this, P and A by V square will have the same units. Yes or no? P, pressure, and A divided by V square should have the same units. And V and B should have the same units. Clear about the point? Whenever if you see these type of expressions, this point you have to understand. So P and A by V square should have the same units and as well as same dimensions, and V and B also should have the same units and as well as the same dimensions, right? Now simple. So P, according to the dimensions I am writing, not according to the mathematics. Don't tell, sir, P plus A by V square, how you can write as P equals to A by V square? Yes or no? So according to mathematics it's wrong, but according to the units I am talking, only according to the units and according to the dimensions, not according to the mathematics. So you have to multiply the things and you have to do generally, but according to the units and dimensions, same quantities can be added and same quantities can be subtracted. So P and A by V square should have the same units and as well as the same dimensions. Now from this I can calculate A. Right? So what is dimensional formula for pressure? Force per unit area. So Force ml t to the power minus 2 divided by L square. So it will be minus 1 minus 2. Right? So ml t to the power minus 2 force divided by L square. So it will be minus 1. So which is equals to A upon V. V is what? Volume. So volume in the sense, can I write L cube whole square? L cube whole square. Clear about the point? So L cube whole square. So I can write as L cube and L cube. So it will be 3 plus 3, 6. So L cube whole square is what? L to the power 6. So therefore, A which is equals to 1 in M minus 1 in L minus 2 in T and L to the power 6. So finally, A I can write as 1. So minus 1 plus 6, 5. 5 in L and minus 2 in T. So this is it. If they ask about find the dimensional formula for B, start. Find the dimensional formula for B. So what I can write? B minus B. In the sense both are having the same dimensions. So I can write B equals to B. So B dimensional formula which is equals to 3 in L. Right? Next. 43. Read the question. If it is same model, start. Okay. 43. Okay. So same method, same model, start. So they gave an equation y which is equals to a sine omega. Okay. So x by v minus k. So omega is an angular velocity and v is a linear velocity. We want v. Linear velocity and x is distance we know. Yes or no? They didn't mention. So we know x is what? X is the distance and find the dimensions of k. So the same model again. Find the dimensions of k. So y equals to this one into x by v minus k. So again here a subtraction concept is there. Getting the point? Subtraction concept is there in the sense what? Same terms can be added, same physical quantities can be added and same physical quantities can be subtracted. So I can write again this term as x by v which is equals to k. Can I write? Clear about the point? Or if you according to the limitations, sine is a trigonometric function, it shouldn't have any dimensions. It shouldn't have any dimensions in the sense what? X by v minus k also shouldn't have any dimensions. So according to that also you can do. Or according to this also you can do. So which is the addition or subtraction based on the same physical quantities, the unit of x by v and k should be same. Now start doing. So x is the distance, dimensional formula L, and v 1 in L, right? So minus 1 in T which is equals to k. So these two will be cancelled. So t to the power minus 1 will go to the numerator. So therefore k which is equals to 1 in T will be your correct option. Understand? Whenever you say addition subtraction, don't think more. So try to equate and get the dimensional formula. Okay? And next 44. Dimensions of kinetic energy. Kinetic energy is nothing but energy itself. So already we know energy dimension formula. Many times we have written 1 in M, 2 in L, minus 2 in T. So that will be the dimensional formula, right? So whether it is kinetic energy, potential energy, heat energy, whatever the types of energy it might be, dimensional formula is same. Okay. Next 45 torque. I think today's class we have seen what is formula for torque. Answer yourself. What is the formula for torque? Force into perpendicular distance. So force we know, perpendicular distance in the sense it's a dimensional formula for L. So you can write and you can multiply. Yes or no? All right. And next 46, the dimension of the ratio of number 46. The dimension of the ratio of angular to linear momentum is, in the sense ratio of angular momentum to linear momentum is. Yes or no? So the ratio of angular momentum to linear momentum is. So I think we know the formulas, right? Try to go with the formulas. Angular momentum formula mvr. Yes or no? Linear momentum formula, just mv. So mv will be cancelled. So according to them, we got it as r. So r is what? Perpendicular distance. So that is nothing but distance. So we can write 1 in L. So that will be the dimensional formula. See, as 1 in L in the sense what? So if you write a proper dimensional formula, it will be 0 in M, 1 in L, and 0 in T. Proper representation. Just according to the story, I have written like this. Okay? And next. Okay, so we'll write here. Next, 47. The pair having the same dimensions is. I think you can do now. The pair having the same dimensions is angular momentum and work. So angular momentum. Here only we have MVR. So work in the sense what? Energy. Work in the sense energy. Write the dimensional formulas with me now. Don't see. Try to write yourself. And angular momentum. So MVR, so I can write it as 1 L square T to the power minus 1. So see, both are same? No, right? Next, work and torque. So work again is a unit of energy. Take this and I write only for torque. So torque is nothing but force into perpendicular distance. So work is also force into distance only, no? Getting the point? Force into perpendicular distance for torque. For work, that is also force into distance. That's not perpendicular distance there, but force into distance. So according to the units, same. According to the dimensions, it is same. So second option is the correct option. Now third option you can check. Potential energy is nothing but work. Linear momentum, that is different. Next, kinetic energy, again work. Velocity, that is different. So option 2 is the correct option. Right? Next, 48. Read the question. Dimensions of surface tension. I think we have seen, right? So surface tension, force per unit length, dimensional formula mLT to the power minus 2 divided by 1 in L, right? So 1 in L will be cancelled. So 1 in M, 0 in L, minus 2 in T, right? So 49. So in the following list, the only pair which have different dimensions is, in the following list, the only pair which have the different dimensions, not same, different dimensions. See, linear momentum and moment of force, Planck's constant and angular momentum, pressure. I think if you have the different terms, I will tell that term, you have to check. Okay, so linear momentum, I think we know, first option, linear momentum formula MV. You can write the dimensional formulas. Start, I will tell the correct option. Next, moment of force. Moment of force is nothing but torque. Torque we call as moment of force. Force, moment in the sense rotational effect of force, right? So torque formula, force into perpendicular distance. So what they are having, they are asking what is the only pair which have different dimensions. By seeing you can tell MV, FS, different. Yes or no? Remaining things, if you don't know, I will tell the formula for that. Okay, Planck's constant we have seen in the today's class. Angular momentum many times we did. Pressure we know. Modulus of elasticity. Modulus of elasticity is nothing but Young's modulus. Is a type of Young's modulus. More types of modulus of elasticities will be there. So 3 types. You will get in mechanical properties of solids again. This Young's modulus is one of the type of modulus of elasticity. So modulus of elasticity and Young's modulus both are same. Young's modulus and modulus of elasticity according to the units and according to the dimensions both are same. Don't worry about that. So why I'm writing another name of that or another concept of this which is having the same thing. So you know this. So that's why. Okay. So both having the same dimensions and the same units. Next, torque we know, and potential energy, that is nothing but energy, right? Clear about the point? Now you can check all the things, but I have proved the first option is the wrong option, sorry, correct option, but According to the story, that is wrong. Why? Both don't have the same dimensions. Okay. Next, 50. Very important model. I think 4-5 questions are there. Try to listen the first question properly. The remaining questions you can do. So I am not doing in the board method. So option checkings, very important. Within 1 minute we can solve this instead of doing that derivation. Okay. So say 50. Now velocity, V is what? Velocity. A is acceleration and F is force. Velocity, acceleration and force. Velocity, acceleration and force are chosen as fundamental quantities. Concentrate, listen, don't write. Listen, are chosen as what? Fundamental physical quantities or just fundamental quantities. Okay. Then the dimensional formula of angular momentum they want. Find the dimensions of what? Angular momentum. Find the dimensions of what? Angular momentum in terms of these three, V, A and F. Concentrate. Very important. So they, instead of considering mass, length and time, consider, instead of considering mass, length and time, they considered here velocity, acceleration and force as fundamental physical quantities. They changed the things according to them. That they are not changing the system. According to this question, they are assuming that. Don't worry about the point. Okay. So velocity, acceleration and force are the fundamental quantities. Now angular momentum dimensional formula, if I ask, I think you will tell mvr, which is implies 1 in mass, sir. So 2 in length, sir, and -1 in t, sir. Okay. But according to this question, I don't want in terms of ml and t. I want in terms of va and f. Consider point is clear. So m and t are the fundamental physical quantities, but according to this question, so what are the physical quantities? Fundamental quantities, which is v, a and f. Now for this, generally you will consider it as v power x, a power y, f power z is directly proportional to angular momentum, and you will derive. You will get some equations and you have to solve the equations. Okay, so that definitely you have to write in the board level. Now we'll see option checking. Option checking. Concentrate. Take the first option A. Take the first option A. So what is that? F a to the power -1 and b. Right? So f a to the power -1 and b. Now check the things. Force dimensional formula. Concentrate. I am not writing x, y, z, and I am not trying to calculate x equals to something, y equals to something, z equals to something. I am going the reverse way. So I consider first option. Force dimensional formula we know. What is that? ml t to the power -2. And what is a? Acceleration. So l t to the power -2 whole to the power -1. Simple method. See, v indicates what? Velocity, right? Yes. So l t to the power -1. Right? Now calculate this. So 1 in m and 1 in l. So you can write direct shortcut also. So in one step it will be completed. But okay, first option also I am deriving. From next option I will write in one step. Okay. So here -1 is there, right? So l to the power -1. L to the power -1, minus of minus plus, so +2, and again l to the power 1, t to the power -1. So any cancellations? Say -1 plus 1 cancelled, and -2 plus 2 cancelled. So what I can write now finally? m1, right? And l1 t -1. So but what we want? Angular momentum dimension formula is what? 1 in m, l square and t -1, but l square is not there, so this option is wrong. Right? Likewise, you can check the options in one step and you can go to the correct option if you get these two are same. Clear about the point? Now take the second option. Take the second option. What is that? F v cube a to the power -2. Right? So f ml t to the power -2. Right? So v velocity. Can I write directly? Velocity is what? L t to the power -1 whole cube. So it is L cube t to the power -3. Clear? L to the power 1 whole cube, L cube, T to the power minus 1 whole cube, T to the power minus 3, and A is what? Acceleration, L T to the power minus 2 whole to the power minus 2, right? So L T to the power minus 2 whole to the power minus 2. So what I can write now? L to the power minus 2 and T to the power 4. Yes or no? T to the power 4 or T to the power minus 4? Minus or minus plus T to the power 4. Calculate this. Any cancellations? See? So it is 1. So here see 1 plus 3 4, 4 minus 2 2, right? And time minus 2 minus 3 minus 5 plus 4 minus 1. Both are same. See, 1 in M, 2 in L, minus 1 in T. Yes, correct. So B is the correct option. Understood the thing? So take the option and substitute your dimensional formulas according to the force, according to acceleration, according to the velocities. Now, what they gave that physical quantity dimensional formula, and if you do this, that dimensional formula, if it is same, okay, or else strike off that option and go for the next option. Right? Now here I got the same, so second option is the correct option. Clear? Follow this method for these types of questions. It will be easy. Next. Okay. Next question. 51. The physical quantity has no dimensions. We know strain. Right? We discuss. Next, M1, 1 in M, minus 1 in L, minus 2 in T represents. So stress, Young's modulus, pressure, and all the above 3 quantities. In the sense, 3 are same. So if you do, I think you will get the same. So fourth option will be the correct option. Why? Because all the above they give. All the above they gave in the sense A, B, C. By seeing, we know those 3 will get the same dimensional formula. So we can go for the fourth option. Right? Next, 53. 2 quantities A and B have different dimensions, which mathematical operation given below is physically meaningful. Already I think we discussed today. I think the question number 42 and 43. Same dimensions or same physical quantities can be added and same physical quantities can be subtracted. Yes or no? Same physical quantities can be added and same physical quantities can be subtracted. But here what they gave? Which mathematical expression given below is physically meaningful when A and B are different dimensions? Option B, wrong. Option C, wrong. Option D, we'll see after option A. Okay, so option A by B. Yes, chances are there. So we can divide or you can multiply the different physical quantities, but we can't add and we can't subtract. So option A is the correct option. Clear? Next, given that V is speed, okay, 54, right? So given that V is speed, so V represents speed, right? And R represents radius, and G represents acceleration. So which of the following is dimensionless? In a sense, what you have to get? 0 in M, 0 in L, and 0 in T we have to get. So we'll check with the options. First option, V square divided by RG. So V square, try to check. With dimensions can we go? So 1 minus 1 square, and R is 1 in L, and L to the power minus 2. Right? Now L square to the power minus 2 divided by L square to the power minus 2. Yes or no? Bases are equal, you can add power, so 1 plus 1 is 2. So both cancelled. So finally we got 0, 0, 0. So no need to check other options. First option is the correct option. We got the dimensionless quantity, which is V square by RG. If we got some dimensions, then we have to go for next option. Again, option check. All right. Next, 55. The physical quantity which has the dimensional formula of the thing what they gave. So if you don't know, I will tell the things. If you know, I'll leave that. So surface tension we know. Density, mass per unit volume. All right. And a solar constant. Solar constant formula is energy per unit area per unit time. The formula for solar constant is energy per unit area per unit time. We call it as solar constant. Now we know that. Don't worry about this. We will get in heat concept. We will discuss there. Okay. So energy dimensional formula we know, area we know, time we know. Try to remember the formula for solar constant. Right. So compressibility. Compressibility. So compressibility and bulk modulus are inversely proportional to each other. So again, you will get in the solids. I think little new term for you, compressibility, which is inversely proportional to bulk modulus. Already we know about bulk modulus. Not that word. We know about modulus of elasticity today. According to the units we are discussing. According to the units we are discussing, not about the concept. This concept will get in mechanical properties of solids. We'll see there. Don't worry about that. Okay. So now modulus of elasticity. I said many types are there which comes under modulus of elasticity. This Young's modulus already we got. Now another type of modulus of elasticity is bulk modulus. What is that? Bulk modulus. So compressibility is inversely proportional to that. So modulus of elasticity dimensional formula is equals to Young's modulus, right? So Young's modulus and stress both are same. So I can write compressibility is equals to 1 by stress. Right? 1 by bulk modulus. Bulk modulus is nothing but again which is the type of modulus of elasticity. So according to the units we can go for stress. So it will be 1 by stress. You can write the things and stress dimensional formula you know and you can substitute here. Right? So all the four options, the formulas I think you know now. Right? And next 56 again the same model. 56 again the same model. See now pressure, velocity and time are the fundamental physical quantities. The dimensional formula of what we want? Dimensional formula for force we want. So pressure, velocity and time now are the fundamental physical quantities. We want the dimensions of force. Okay, start option checking again. First option I think you can do now. So P V square T square. Now start force dimensional formula in terms of mass. 1 and minus 2. Right? Now we want this from this. So pressure dimensional formula force per unit area. So it is M divided by L square. So -1 -2. Should be quick. Force pressure is what? Pressure only no P, right? Force per unit area. So force divided by L square. So it will be -1 -2 1. Clear? Now what is V? Velocity. Velocity direct can I write? So L t to the power -1 whole square. So 2 in length -2 in time. Now what is T? T is time only. So you can write it as T square as it is. Now calculate. We'll get or not. We'll check. Mass. There is no other mass. So 1 in mass. And next -1 plus 2. Right? -1 plus 2 plus 1. And -2 plus 2 cancelled, so another -2 is there. So we got the same. So first option is the correct option. Understood? So what they asked to calculate for force and what they gave, I checked and I got finally the same. So these two are same. So this thing which represents the correct option for the force in terms of the fundamental physical quantities of P, V and T. If you derive, I think you will derive like this: P to the power X, V to the power Y and T to the power Z. what you have to get actually, see here, p to the power 1 is there. So x value will get 1 and y value you will get 2 and z value you will get 2 again. Then you will go for this option after deriving that. Then instead of deriving in one step, I did. Understood, I think, right? Next, 57. I think energy divided by mass into length. Energy dimension formula you know, mass you know, length you know. Then I think force you know, power you know, pressure you know, and acceleration you know. No new terms are there. I think you can do that. 57. You have to get the fourth option. Fourth option, right? Next, 58. Same method. I'm leaving that. Please do that, right? So 58. Same method. Same method. So energy, velocity, and force, fundamental quantities. Then what is the dimensions of mass? Do the same method and you have to get second option as the correct option. Those options also I am telling what you have to get. Next, 59. Pressure gradient has the dimensions of 59. Whenever if you see gradient concept, whenever if you see gradient, that indicates per unit length. Remember this, gradient which indicates per unit length. Pressure gradient, temperature gradient, whatever the things according to the dimensions I am telling. According to the concept, that is a pressure difference by length or temperature difference by length. What is the difference at all you will get in that particular chapter. But according to the dimensions, whenever if you see gradient, first you have to remember it is divided by length. Now here they gave as pressure gradient. So pressure per unit length will be your formula, and pressure dimensional formula you know, and length also you know. You can substitute and you will get, I think, pressure gradient has the same dimensions of they are asking. Velocity gradient, energy gradient, potential gradient, none of this. I think the formulas I will tell. Velocity gradient is what? Velocity per unit length, right? Potential gradient per unit length. I think potential things also we know. For potential dimensional formula we know. What is potential dimension formula? Work done per charge. I think this one and this one won't be same. Alright? And next, velocity per unit length. Velocity and pressure same? No. And energy gradient. In the sense, energy per unit length. So try to see this dimensional formula and this dimensional formula should be same. If it is same, you can go, or else you have to go for none. Okay? Next, 60. Again the same thing. Say force, length and time are the fundamental quantities. Instead of PVT, you have to consider force, length and time. Then the dimensional formula of what? Mass they ask. See option checking. Try to go with the option checking method. I think you understood this method. You will get, I left 2 questions, 58 and 60. Please try to do that. Okay? Thank you. Bye.